Hello and welcome to What's New in Aerospace. I'm Marty Kelsey, one of the hosts of STEM in 30, an Emmy-nominated TV show for middle school students. We have a great program for you today. 2 weeks ago, we launched balloons from across the country, everywhere from Washington, D.C. all the way to Alaska. And at least one of those balloons is still traveling around the world. And we've got some folks to talk to you about that today. I want to remind everybody watching that if you have questions about this project, how you could use it in a classroom, or anything about how these balloons work, submit those down in the comments section, and we will try to get to as many of them as we can today. Also, let us know where you're watching from. We'd love to give you a shout out. To get us started today, let's look back to that launch 2 weeks ago as we sent balloons around the world. All right, we're going to launch in 5, 4, 3, 2, 1. Let her go. There it goes. The exact opposite way we had predicted earlier. If you're near Sterling, Virginia, look out your window and see if you see it go by. And you get bonus points if you snap a picture of it. Oh, let's get a little lift going. Looks like we've got good launches from across the country. I'm seeing other feeds. Oh, this is cool. That is really cool that a balloon that size is going to make it all the way across the ocean, and in some cases all the way across the country and then across the ocean, aloft for 2 weeks. Absolutely amazing, amazing stuff. As you could tell, I was a little excited about those launches, and I'm really excited to be joined today by Trevor MacDuff, a member of the Teacher Innovator Institute, who you saw in the video. We've also got Audrey and Jack. They are students who use balloons to help inspire other students in STEM fields. And Neville Miller, a meteorologist at KMBC9 News, my hometown, Kansas City. Thank you all so much for joining us today.
Thanks
Thanks
Marty.
for having me.
Thanks.
All right, so reminder, let us know where you're watching from. We've already got folks from Texas, Massachusetts, Virginia, Indiana watching. Let us know where you're watching from, and let us know what questions you have down in the comments section. Trevor, I want to get started with you because this is pretty cool. Give us an update on your balloon that you launched, I think, 12 days ago.
Yeah, I'm pretty excited right now, Marty. Our balloon actually made it all the way back around the world. We launched it from right here in Richland, Washington. And around 4 in the morning a couple days ago, it kind of drifted past us. Because it's solar powered, I call it woke up in Montana, because that's when the sun came down and charged it up and the capacitor could send out a ping. And so we watched it that day, but it was in the jet stream. It was moving hard and fast. And so it woke up in Montana, it fell asleep in Minnesota, cut through South Dakota that day. Then overnight, it kind of swooped up north over the Great Lakes, up through Quebec. Fellas, it could have woken up, but it's on the APRS network. And if there's no repeaters, there's no way to know exactly where it is, but we have some good predictions from the weather patterns. And right now it's out in the middle of the Atlantic Ocean, kind of about to do some pirouettes, I think, if I read my prediction correctly.
Awesome. And we'll get into the predictions again here in a minute and really talk about how ham radio is involved with this. But Audrey and Jack, tell us about your balloon that you launched that day. You all had some weather difficulties, right?
Yes, we did. So we live in Northeast Georgia. And when I looked at the wind predictions about a week ahead, I was looking and it showed all the winds where we were. We're heading straight into the eye of Hurricane Delta, which was actually it was a little southwest of us. And I was really worried about that. So I'm like, okay, we'll drive north. So we drove all the way up in Tennessee, launched from Smyrna, Tennessee. And even though we launched that far north, we still experienced some winds. And unfortunately, we believe our balloon got caught up into the storm. But, that's how it is. But it was a fun learning process. And actually, our launch was perfect, right? It went straight up.
Yeah.
But yeah.
It's all part of science.
Yeah, exactly.
All right, Neville, tell us, what do these balloons show us about the wind currents?
The great thing about these balloons is it's going to follow the track of the wind. And so as that balloon gets higher and makes its way up into the jet stream, when these balloons start getting to 30 to 40,000 feet, you really get up into that jet stream level, and it's going to follow along where that wind is going in the jet stream. And so I was looking at some of the tracks on some of those balloons that were launched, and you can see how really it followed along with the jet stream. You can kind of get an idea if you look at the distance the balloon covered in the amount of time. You can kind of see how fast that balloon was moving. And we know the jet stream, on average, it's about 110 miles an hour, but it can be up near 200 to 250 miles an hour. So it really helps you see where the wind is moving in middle upper parts of the atmosphere.
Awesome. All right. Well, we've got a few questions coming in. A reminder, please ask those questions down in the comments section. We want to try to get to as many of them as we can. We've got Argentina, the Netherlands, South Africa, and Chile joining us, as well as Ohio, Maine, Michigan, Puerto Rico, Pennsylvania, and Illinois. So we've got folks watching from all across the country and all across the world. Maybe if this balloon makes another lap around the world, y'all can go outside and wave at it as it passes by. Trevor, and this is a question for you, and I think it's two parts. Somebody wants to know what kind of balloons we're using, and we actually used a couple of different kinds. Tell us about what the one that we're tracking around the world is.
Yeah, I use I call it an SBS-13 scientific balloon, super pressure design balloon. It's polyethylene. It's about 0.001, 1/1000th of an inch thick, heat welded. It's 7 feet long, 3 feet across, kind of ovalish shaped. And it's designed for exactly this. I filled it up with a very small measured amount of helium. What we're showing there is the Mylar balloon. Those are a 3-foot Mylar party balloon that comes with the kit that I buy. But I went ahead and bought the upgraded balloon because I wanted to get a little bit higher in the atmosphere, really hit that jet stream and get some of those 150 to 200 mile an hour winds and see if we can get around the globe. And we did. The SBS balloon takes you above a lot of the weather. And so I don't know if it would compete with the hurricane at all. That's something we'd have to test out. But it definitely takes you above the vast majority of storm systems that can really weigh your balloon down.
And Audrey and Jack, you all have launched both kinds of balloons. Which one did you launch 2 weeks ago?
Yeah, so we opted for the Mylar balloon. We had, I think we actually have some super pressure balloons on the way. But yeah, so we did a 3-foot Mylar balloon, which is similar to what you would see, if you go to the store, you look at Mylar balloons. It's just a big round circle balloon, just like that. And we launched that with the PicoSat. So it turned out pretty well for us at first, but it did not hold up with the storm.
Yeah, sadly, Hurricane
Delta had other plans for our balloon.
And Hurricane Delta probably took it out past the coast, probably.
Yeah, it's probably in the ocean.
Mm-hmm. Okay. Neville, how do these balloons compare to weather balloons that we always hear about?
So with the weather balloons, they're typically going to launch those twice a day. You're not expecting those to go all the way around the world. So what they're doing, where I am in Kansas City, they launch them around here. They have one out in Topeka that they launch. And it gives us an idea. We're just trying to see what the atmosphere is doing from the surface up towards that jet stream level. So about 300 millibars, about 30,000 or so feet up. And so with a weather balloon, we're just trying to get an idea of the temperature, the pressure, the moisture in the atmosphere, mainly in that specific column of air in that region or in that area. And we do these all around North America, all around the United States. And then that data then is input into the computer models, the forecast models that we use, and it helps us get a better idea of what's going to happen with our weather. So with the balloons that we're talking about here, for the you guys are sending them around the world. With a weather balloon, you're more so sending it up, trying to get those conditions in more so one particular column of air, if that makes sense.
All right. Reminder, please put your questions down in the comments section. We'll get to as many of them as we can. We've got Georgia, Oregon, Washington, D.C., New Jersey, and Paraguay all tuning in. Let us know what questions you have. And I've got a challenge for all of our viewers. Try to stump our panelists. We've got a meteorologist and an amazing teacher and a couple of students that do incredible work getting other kids excited about STEM. So let us know what questions you have. And I think this next question is really an important piece. And Trevor, you touched on this a little bit. Talk to us about the technology used in these balloon launches.
Yeah, these balloons operate. I had to get my ham radio license to do this. It operates on radio frequencies transmitting on a 2-meter band, and it uses the APRS network. It's a network of repeaters all around the world. And a signal goes out, and then they all kind of share the signal, and you can track it through some internet sites. And so I've been able to keep track of my balloon every time it was sending out a ping, and there was a radio receiver to pick it up. We're actually hoping here sometime. Yeah, that's the tracker right there. So you're looking at the kind of the top side of the solar panels, and there's guitar strings soldered in there to act as the antenna. And the top one actually clips to that red string right there, just to make sure that you're all stretched out nice and long and give out a solid 2-meter band. Yeah, APRS network. There's another network out there, and I think that Audrey and Jack can talk a little more about this, because it's called Whisper Network. I haven't used that one yet, but they've been hamming a lot longer than I have. And so this ham radio stuff is fairly new to me, but I'm pretty darn excited by what it can do and how it can impact my classroom, especially with these sky trackers.
Audrey and Jack, tell us about the Whisper Network.
Yes, so the Whisper Network, Weak Signal Propagation Reporter. It's actually a program that was designed by a man who won a Nobel Prize named Joe Taylor, who actually also won or is a ham radio operator.
Yes.
So the difference is with the APRS balloons that we launched a couple weeks ago, they're transmitting on 144 megahertz here in the US, 144.390 megahertz. And their antennas, as you can see, are pretty short because they're tuned for that exact frequency. On the other hand, we've launched balloons that work Whisper.
And they have big 20-meter antennas, which usually have a length of 10 meters, which are very long.
Yes.
And they also usually have quite big balloons, usually, big SBS balloons or big latex balloons.
And the difference is that they actually transmit on 14 megahertz. And the reason why it's called Weak Signal Propagation Reporter is that the program it's able to decode these very, very, very weak signals on the 20-meter band, 14 megahertz. And it works the same way as APRS. It reports them online, and you can just go and search your call sign up and see where you are. And the nice thing is that with APRS, you have to be near an eye gate or near a repeater, right, for it to show up online. But with WhisperNet, you're running on 20 meters, 14 megahertz, which means you don't have to be close to an eye gate, because the difference is on 144 megahertz, you're in the VHF range, the very high frequency range, which means line of sight. Yeah. So you have to be in distance of a repeater. While 14 megahertz,
14 megahertz, it can reach extremely far, continents far. And so it can reach, like, let's say you're in Northwest Territories in Canada, it can reach I can probably reach you down in Georgia.
It runs on the HF band, the high frequency band. So that means that here in my house, we could pick up a Whisper balloon that's, all the way over in Europe, So that's pretty cool.
That's incredible. And Neville and Trevor, how impressed are you with these two students? And Audrey, you're in 11th grade, and Jack, you're in 7th grade, right?
Yes.
Yeah. No, I'm the student here. I'm learning from them. So, yeah.
Neville, talk to us.
I'm learning too, hearing about the ham radio stuff.
Neville, talk to us about how do you get the data back from weather balloons?
So the Weather Service offices, they're going to be the ones launching those balloons. And so they'll launch it. They'll get the data from the different layers of the atmosphere. That data then goes to another server. And essentially what they'll do is they'll put out maps. Anybody can access them. But they'll put out a map, and it'll give us an idea of what the atmosphere, for example, the one I would use would be from Topeka, which is the closest one here to Kansas City. And it lets us see from the surface all the way up to the jet stream level, the temperature, the dew point, the wind speeds, very important information that then I can take and use if we have a day where there may be severe weather, like today, actually, there may be some thunderstorms this evening. I can look at that map and I can see what is the atmosphere like in the morning and what is the atmosphere like when they do that second balloon launch in the evening. And I can see how is the atmosphere adjusting, what are the changes that are being made as we go through the day, what's happening in the atmosphere. And then they can also create a nationwide map, which also anybody can access those. And so I can look at those maps and see, well, I want to know not just how's the atmosphere in my specific location, but what's happening around me. When it comes to weather, it's so important to know not just where you are, but what's happening around you, what's happening upstream, what's happening downstream. So I get the data and I can look at what's called a SKU-T map, so my specific area of the atmosphere, and then I can look at an upper air map, whether it's a 500 millibar map. You had one of those maps up there a moment ago, a 300 millibar map and look at the jet stream, a 700 millibar map and look at relative humidity, 500 millibars. I can look and see, are there areas of active weather above me that may lead to more cloud development, thunderstorms, snow. What do the temperatures look like above me? Are we going to have snow, freezing rain, sleet? So the data that we get from weather balloons, the data that we get from these balloons is so critical, because then that data also goes into those computer model forecasts, which is what all meteorologists, we use to help forecast the weather. So that data is just so critical in helping our models be more accurate, and of course, helping us become more accurate too.
Awesome. It seems like a lot of it comes back to math and data. And Trevor, can you talk to us a little bit about how you're using this in your classroom?
Yeah, we're tracking it. I mean, this is kind of ideal virtual education. You know, we're not meeting in class yet, and we don't need to right now. We can track this balloon. We can use the NOAA high split model. That's the National Oceanic Atmospheric Administration. They have an online model generator, so my kids can daily update with our GPS and altitude data that's coming back from the telemetry, and we can use that the null school that was the map that we just saw that showed the jet stream flowing through, and we can make some predictions about where it's going to go. Beforehand, we were talking about buoyancy. How do things float? Why do things float? Radio waves. What's the difference? You know, we got Audrey and Jack talking about 14 megahertz and 144 megahertz, and what does all that mean? And all of those are next generation science standards. All of those are a part of learning. And I launch one balloon and I can spend weeks talking about the data. My class is actually downloading the data into some ArcGIS software, and we're making some comparisons between what kind of solar energy do we have versus what's the speed doing to see if there's a tilt on the solar panels. Can we find some patterns in the temperature versus the altitude? But not only that, because I'm an integrated teacher with, there's a history teacher, she can look at a map like this right here, and we can start talking about why are there different rules and regulations over different countries. We get into the civics of it. We get into why is Yemen blacked out? Why is North Korea blacked out? What's going on in these different countries that make different laws that seem like it's just a radio. One balloon and my virtual learning is set.
That's amazing. And I know that there are teachers across the country doing things just like this to get their kids engaged and excited. And Audrey and Jack, you two use these balloons to help work with other students on STEM topics, right?
So I think it was actually in January this year, early, I went to a elementary school in our school district, and there were a bunch of first graders. They were so excited, and I incorporated, we launched an APRS balloon, just like the one we just saw. I incorporated weather into and so we talked about, I took everything down to the first grader level, and I'm like, well, let's talk about weather. Let's talk about what the sun does to the wind, and all that. So it's definitely, ballooning is definitely unique because you can tailor it to any age group and any education level, So that's what it's always fun to educate kids with it.
Awesome. And Neville, I think you and I actually met a long time ago when you did a school visit in Kansas City. I was a teacher there for a long time. Tell us what's your big message when you talk with school kids?
When I talk with school kids, that's a great question. And just like Audrey and Jack, if you have an interest in science, there are things that you can start doing at a young age. Like if you want to do my job and be a meteorologist and work on TV, there are ways you can be interactive with science. There are so many fun aspects of it. There are things that we're learning all the time. I'm learning stuff about these balloons and the ham radio things that they're doing, which I think is great. So, I really just try and teach kids that science can be fun. There are certainly some complicated aspects of science, and it's kind of something you learn in layers, but you're never too young to learn. You're never too young to get started. And, it could be something as simple as using the balloons and showing how, as they were mentioning, how weather can impact those balloons and what we can learn from these balloons, what information it can give us. So I really just try and get to kids that, hey, you're never too young to get started on this and learn what you can. Weather impacts all of us, So I think the more you can know about it, the more educated that you can be, the better decisions you can make when it comes to your daily life. And for me, it's just such a fun topic, and I love seeing people learn about it.
Awesome. All right, we've got a question that's coming in a lot, and I'll put this to all three of you. Are you all concerned about the ecological impacts of these balloons as they go around the world, and maybe we don't know where they end up and potentially, land somewhere that it impacts animals or anything like that? Any concerns there?
Well, a lot of times you want to use the least materials possible. First of all, because of weight, but second of all, really all the ecological things. You don't want to be putting in like a bunch of extra counterweights or something, because those could.
Yeah, I mean, like compared to what we're doing is the APRS balloons compared to HAB balloons we launch. HAB balloons have a lot more things carried on them and they can get lost. But actually with these APRS balloons, what people are able to do is they're able to launch them, see where they land, and then call people to actually retrieve them so that they're actually being removed from the environment. And, they're at least not there.
And Neville, are weather balloons the same way? Do you guys put an address for people to mail them back if they find them?
Yeah, that's kind of how the weather service works. So, they're able to track where that balloon goes. And people can call in and say, hey, we found the weather balloon here. And then that way they can get it back so they're not being littered or polluting parts of the area.
I know the museum, part of our SheCan aviation camp, launched a high altitude weather balloon. And a couple of our staff members had to go buy a tree trimmer to get it out of a tree and retrieve it at one point. We've got a question from Shauna, and she wants to know what kind of science or what can you do best from balloons as opposed to sounding rockets or orbital spacecraft? Have we stumped our panel here?
Well, I have never had the opportunity to launch an orbital spacecraft, so I'm going to have to work on that. So I've got a comparison. I think what you get with that is the balloon is cheap. It's very inexpensive. I mean, especially compared to an orbital spacecraft. But a sounding rocket, while fun, I've done the high altitude balloons, and the high altitude balloons are fun. You can put you can put a few kilograms on there, so you can get your GoPros and you can get some, you can put batteries on it so it keeps going. But this Pico satellite is 12 grams. I mean, it's lighter than a AAA battery. It's just crazy how light this thing is. But then it goes up and it stays up. So there was one person who had theirs lap the globe 22 times. And as it went around, it took over a year. And so when I think about these balloons, if I spend a couple $100, get a balloon, fill it with helium, put a Pico satellite on it, and it just keeps going, and I can learn for an entire year from $200, that's a heck of an investment. I'm very keen on that. Granted, if somebody gave me the opportunity to go into an orbital spacecraft, then I'd be willing to give up ballooning.
And Neville, how does the data that you get from the weather balloons compare to satellite data that you use?
It's just different types of data. So a satellite, a lot of times we're going to use that to look at clouds. We can see temperature as well using a satellite. So that's how a lot of times we'll see sea surface temperatures, especially when we have tropical weather going on. Clouds in the tropics, we'll use those satellites for sure. But when you're talking about a balloon, this is something that's in the environment, which just is critical. So you have something that you're launching from the surface and it's going to go up through the atmosphere. It gives me that actual reading as it moves up in altitude, which is so important. Whereas your satellite, if it's up in space, it's giving us that remote view. So, I'll definitely take that actual reading from the device that's going through the atmosphere, and use that with the data that we get from the satellite, that remote data from the satellite. So they kind of go hand in hand, but if you have both of those sets of data, you can just do so much more with it.
All right, we've got a question. Somebody wants to know how we can track your balloon, Trevor.
APRS.fi. It's a website out of Finland. APRS Alpha Papa Romeo Sierra .Foxtrot India. APRS.fi. And you type in KS1LAS. It's a kind of an acronym for K Silas, but it's a 1, not an I. But KS1 LAS-1, that's my balloon. And I'm hoping, depending on when the sun goes down, the Azore Islands are kind of north of off the coast of Africa. And I'm really hoping that it pings over there today, because that's kind of where it's supposed to be. If we don't hear it ping there, then it might be a couple days before it finishes dealing with, there's a hairpin turn in the jet stream, and then it's got to poke over to Africa. And so, that's definitely our goal, is to keep going. So I hope it pings today on the Azore Islands.
Cool. Audrey and Jack, do you all have another launch planned? You said you had balloons on the way.
Yeah, we're actually planning to do another launch here, probably end of November, beginning of December.
Yeah, about that time.
It should be good, because last time we did a really big launch with an HAB and a picosat, it was the middle of July, and middle of July in Georgia is very hot. So we're planning to do another launch when there's not a lot of heat and not a lot of hurricanes. So this time we should get some really good results. And yeah.
Yeah, and we're also thinking, we launch in our area a lot of times, and almost always it gets caught in a storm off the coast of like North Carolina or Georgia. And so we may go up north to launch them there to see if we can get it past all those winds, try to get around the world.
Nice. Neville, we've got a question. Are there jet streams in the southern hemisphere that would allow a balloon to circumnavigate the Earth in the southern hemisphere?
Yeah, there are. So you've got 2 primary jet streams in each hemisphere. You've got the subtropical jet, kind of hangs out about 30 degrees north. Same deal on the southern hemisphere as well. And these track from west to east. And then you've got a polar jet stream, which is going to pay our area a visit here in about 12 hours. And that one's usually about 50 to 60 degrees north. And those navigate the globe. So again, you've got 2 in each hemisphere. You kind of get a look right there. Not in a straight line necessarily. You have a lot of ebbs and flows there, troughs and ridges. So, as you see in the track of the balloon, it represents that pretty well, kind of going all over the place. So if you are able to get a balloon that's able to stay afloat long enough, you, in theory, can get your balloon around the world. Again, it's probably not going to be in a straight line, but it'll give you an idea of just what those winds are aloft, and you can really just see the path those winds are taking, that the balloon takes as well.
Awesome. Now, Neville, I've got one more question for you. What is going on in Kansas City? Because you guys have had some kind of wild weather the last 2 or 3 days, right?
Yeah, we have. It's crazy because last Saturday we were in the 80s. Sunday through yesterday we were in the 40s and cloudy. I'm wearing a short sleeve polo shirt right now. It's super windy outside. We're almost 80 degrees here. And then tomorrow we're going to be back in the 40s. And so that right there is a good illustration of, hey, when it gets to fall and winter, the jet stream just gets so much more active. And that's why you see way more of these weather changes. In the summertime, you usually don't get big changes in temperature. But as you head towards the fall and winter, that variance in temperature, that is what causes the jet stream to become stronger. It becomes more active. And yeah, that's why our weather has literally been all over the place last even 12 hours. I woke up this morning, it was in the 50s, and now it's almost 80 degrees.
Wild stuff. Well, I want to give a shout out to Bill Brown, who developed the sky trackers that are used on these balloons. And he's done some incredible work, and we appreciate all of his help, mentoring Trevor and some other of our teachers on getting these balloons to be able to be launched and tracking them with their students around the globe. And if you're interested in a project like this, you can send an email to stimmin30@si.edu. And I think that email address will come across the bottom of the screen here. Send us an email and we'd be happy to get you that information on how you can get involved in your classrooms. We're just about out of time here. I do want to encourage everybody that if you want to learn more about ballooning, you can check out the most recent episode of STEM in 30. It was all about balloons, both gas balloons and hot air balloons. You can also go check out our most recent live chat we had with Bill Costin, who is a master hot air balloon pilot. We got a chance to talk with him last week. And our next show is coming out at the beginning of November, and it's all about the International Space Station. And then we're really excited about this. Coming up on November 12th, we will have NASA astronaut Kjell Lindgren answering your questions live at 1 o'clock Eastern. And before we leave here today, I want to thank all of the teachers out there. You all are facing a year like no one has ever had before. And whether you're in person or whether you're virtual, we know how hard it is. And everybody at the National Air and Space Museum thanks every teacher. And really, we thank you for inspiring that next generation of explorers. Neville, Trevor, Audrey, and Jack, thank you so much for sharing your expertise with us today. And thanks everybody for watching.
Thank you.